Hi everyone, this is Mrs. Watson. I'm just going to give you some notes if you were absent on Tuesday. This is for section 10.1.2, and the big thing we talked about was this definition of complements. And complements means the complement of an event and we're going to say the complement of an event A. We're just going to give a letter to an event A. Like an event could be the probability of you wearing blue jeans tomorrow. Okay, that would be your event. Then the complement of an event A is the set of all outcomes that is not A. So if I say the probability of me wearing jeans tomorrow is 30%, then the probability of me not wearing jeans would be 70%. And that leads us to the following. First off, we say something is a complement by writing the letter with a line over it. That means not. Okay? And we have this formula. The probability of an event A plus the probability of its complement, which is not A, is always 1. And so if we want to find the complement of an event, we can just do the probability of not A equals 1 minus the probability of A. Okay? And this is really useful because sometimes it's a lot easier to find not something than to find all of something, especially when you have lots of different outcomes. It's just a way to limit what's going on. So and that example is when tossing a fair die, six-sided die, the probability of not getting a 5 would be, and we write it like this, the probability of not getting a 5 is equal to 1 minus the probability of getting a 5. Well, if we have a six-sided die, each number has an equal chance of happening. So the probability of getting a 5 would be 1 over 6. Now, if you were here on Tuesday, we talked about how we can change that number 1 into something that's easy for us to subtract fractions. Remember, the denominators need to be the same. So since the denominator here is 6, we're going to change 1 to 6 over 6 minus 1 over 6, and then we just subtract the numerators. Okay? You can also always use your calculator. Okay? So the probability of not getting 5 is 5 out of 6. Okay? The last thing I want you to write, definitional probability, you should have this, but remember that the formula is as follows. And you're going to use this for the back of the worksheet. Okay? Remember that it is the probability of B line A, which is the probability of B given, pardon me, A, is equal to the probability of A and B over the probability of A. Okay, and the trick is finding out the events that are occurring right there. Sorry, there's a little messy there. Okay, right now I want the video to be stopped. I want you to start the worksheet. The first side should be finished, and then if you're struggling with the back side, specifically numbers 1 and 2, let me know, and the video can be restarted so that I can help you and give you some direction for that. Now on to the second part of the worksheet. On the back, when it talks about conditional probability, remember that it says a die is rolled. Okay, so that's just the sample space we're dealing with. Okay, we have a dice, and we know that a dice has 6 sides and numbers. Determine the probability that it is a 4 given that it is greater than 2. So the first thing you need to do is decide what A and B are. Okay, so think about that. What would A be and what would B be? Remember, keep in mind that A is everything and B is just a small, like a condition, something you're pulling from it. So what do you think it could be? I would think that A is numbers greater than 2, and B would be 4, probability of getting a 4, okay, if it's greater than 2, okay? So then let's talk about the formula that we have. Okay, remember it's the probability of B given A is equal to the probability of A and B over the probability of A. So what is the probability of A and B? Well, what's the probability of a 4 and it's greater than 2? Well, a 4 when it's greater than 2, what would that be? Think about that for a second. So if you think about the probability that it's a 4 and greater than 2 would be 1 out of 6 divided by the probability of numbers greater than 2. Well, there's 4, so that would be 4 out of 6. Remember when we multiply, or excuse me, when we divide with fractions, we take the reciprocal of the second and we change the division to a multiply. So it becomes 1/6 times 6 over 4, which gives us 1/4. Okay, the next one that I would like you to do is number 2, and that is, it says a card is drawn from a deck of cards to determine the probability that it's a queen, given that it's a face card. So what's the whole event? First off, our sample space is a deck of cards. The whole event that is going on, I think it'll probably be a face card. And this is for number 2. And B would be that it's a queen. And so then let's talk about what's the probability that's queen and a face card? Well, that's 4 out of 52. There's 4 queens, and those are face cards. So 4 over 52 divided by then the probability that it's a face card. Well, how many face cards are there? Think about that for a second. There are quite a few face cards, and so there's going to be, think about them, 4 jacks, 4 kings, 4 queens, that's 12 out of 52. And then we get 4 out of 52 times 52 over 12, and we end up with 4/12. The next problem, if you're struggling with, just remind yourself that it says to you when it is the newest game in the country fair. First, a player spins a spinner that is divided evenly into sections that are red, blue, yellow, and green. Then a player rolls a die. The player wins if the spinner lands on red and the number showing on the die is even. Show the sample space. My suggestion to you, sort of an area model with the situations that's going on. Perhaps I would do the spinner on top and the dice on the side, okay? And then finish answering the questions. Then next one, number 4, if Leroy studies for his next math test. This is a tricky one, but I would definitely find somebody in class, definitely look in the back at the poster. This is very similar to one that you should have copied down on the poster. It's the 3rd poster about Letitia. Yep, that's what it looks like. Okay? When you finish this, remember the last thing that you need to do is the probability review sheet. Okay? All of the work needs to be turned in by the end of the class period, regardless if you're done or not. Okay? On Tuesday, I got about 6 sheets, and that is not okay. You are very capable of doing way more than that. And I know that, and I am looking forward to seeing what you turn in. Okay? Thank you.